The next topic is transaction and system concepts. A transaction is an automatic unit of a work that is either completed in its entirety or not done at all. This is what we can call it as a transaction. Means it is one of the automatic unit where works that either will going to complete it or else it will not done at all. So that is what we can call it as a transaction. A transaction will going to passes through several states where the figure will going to depicts about the states, how the transaction will going to passes through several states in an with the respect to the operating system. There are some of the state transaction states are listed over here. First one is active state, second one is partially committed state, third one is committed state, fourth point is or fourth state is failed state, and the last state is terminated state. The active states is nothing but where executing the either read operation or write operation. So that we'll going to explain about in the active state. The partially committed states are nothing but ended, but it is waiting for the system to check or to determine success or failure of the transaction. And the committed states are nothing but the transaction which is successfully executed or which is succeeded, that we can call it as a committed state. The failed state will gives a clear idea about the transaction failure, or it must be rolled out back after a failed state. Then terminated state. The terminated state is nothing but the transaction which leaves the system, that we can call it as a termination of the state or terminated state. This figure will going to give a clear picture about the state of transitions. So for the transaction execution, it includes active state, partially committed state, failed state, and as well as terminated state. So always the active states will start with the begin transaction and end transaction. So that is in between there will be some operation like read operation or write operation. With respect to that, the transaction will be undergoing. Now, so we will see the in detail about the each and every state where begin transaction, end transaction, partially committed state, and commit means about. So and as well as about state means when the failure occurred, then the termination of the transaction will be done, and as well as the committed state and terminated state. So the DBMS recovery manager needs system to keep the track of the following operation in the system log file. Means the system log file will going to include each and every uh, step of operations which are undergoing in the transaction. So that will be managed under the system log file. So that DBMS recovery manager is required, so or else he wants to keep the track of the operation where step by step the transaction is undergoing or not, is there any failure or occurred in between. That to check we require a system log file. So now the begin transaction is nothing but it explains about the start of transaction execution. And the second step, which is read or write operation, is there. So this read or write operation on the database items that are executed as a part of transaction, so that will be reading the data or writing the data into the database. Then end transaction, this End transaction will specifies the end of the read operation and as well as write operation. So with respect to that transaction operations which have ended, and then so the system may still have to check whether the changes introduced by transaction can be permanently applied to the database, or the transaction has to be rolled out back because it violates the concurrency control for some other reasons. So based on that, so the end transaction will going to execute and will going to end the transactions completely, either in any one of the manner, like if it is the transaction is executed completely, and then so the transaction will going to abort. If the transaction so in between any failures are occurred, then we require to roll out back whatever the uh, states we are executed. And then if you have made any changes of a data in the database, so in that case, so if the transaction will going to identify whether we have to permanently change to the database or not. Okay, means that is what we are calling it as a commit the transaction. Commit is nothing but which the data will be stored or saved inside the database permanently. Based on that, so these are all the functionalities we'll going to check, and then the end transaction will be performed. The recovery manager will going to keep track of the following operations. So that is the continuation of that. That is commit transaction. The meaning of the commit transaction, which gives the signals successful end of the transaction. That is the meaning of commit transaction, where we have successfully stored the data into the database, or else data has been trans transacted to the destination properly. That is what that whole transaction so will be committed, or else which will going to save inside the database. For example, if we change we have made any changes which are executed by the transaction, which can be safely committed to the database, so and will not be undone. Based on that, the commit transaction will be executed. For example, so if I want to store some data into the database, or else if I want to update the data into the database, so then the data if it is updated properly, then it will be signaled successful end of the transaction. In case if it is not, then so it will going to roll it back whatever the transaction has been done, any errors if occurred during the transaction. That is what the meaning of commit transaction. Commit means so data has been changed successfully and it is saved safely into the database. About transaction or rollback transaction, this abort transaction or rollback transaction will occurs when unsuccessful transaction has been done. Means the signals transaction has been ended unsuccessfully, then any changes or effects that the transaction may have applied to the database must be undone, and it needs to get back to the original state, whatever it is previous state was there. So in that case we have to roll it back whatever the transaction we have done. For example, from one state to another state, and if you already gone through with the 2 to 3 state, if the third state so any transaction failure occurred, then you need to roll it back to the third to second, second to first, and then whatever the original data was there, so we have to return it back to the original database. So that is what the about transaction or rollback so signal will go into indicates. Next topic is the desirable properties of transactions. The desirable properties of transactions, we are also calling it as acid properties. These properties needs to be satisfied so when we are doing the transactions, that is atomicity, consistency, isolation, and durability are the properties of the or desirable properties of the transactions. In short form, we are calling it as ACID or acid properties. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Now, so why we require these properties of our transactions, and what is the meaning of atomicity, consistency, isolation, and as well as durability? The atomicity is nothing but a transaction is an atomic unit of a processing. It is either performed in its entirety or not performed at all. That is the meaning of atomicity. Means when we are talking about the transaction, either the transaction is nothing but it is a one of the atomic unit of the processing, where either it will going to perform completely or else it will not perform at all. That is the meaning of atomicity. Then consistency preservation. The consistency preservation means a correct execution of a transaction must take the database from one consistency state to another. Then that we are calling it as a consistency preservation. Means if the transaction is executed correctly, then the database needs to be carried from one consistency state to another consistency state without any error or without any failure, transaction failure. Then that we are calling it as a consistency preservation. Means there should not be any modification in the data when we are um, uh, doing the transactions, or when we are taking the database from one consistency state to another consistency state, like for example committed or partially committed or else start execution. So in that case the same data needs to be carried from one state to another state. That is what we are calling it as a consistency preservation. The third desirable property of a transaction is isolation. The isolation is nothing but even though the transactions are executing concurrently, they should appear to be executed in isolated manner. That is, their final effect should be as if each transaction was executed in isolation from start to finish. Means the whichever the transaction we are executing, so if it is looks concurrently it is executing, but it needs to be appear like a executed in a isolation manner. But at the end the final effect should of the transaction should be same as whenever we are executing concurrently or in the isolated manner. Therefore this isolation is one of the desirable property which is required during the transactions. Then fourth desirable properties of the transaction is durability or permanency. The durability or permanency is one of the property of the transaction. Once a transaction is committed, so it changes, like that is when we are applying the right operation, so it changes to the database where we have applied to the database. That must never be lost because of the subsequent failures. Whatever the changes we are making the database, that needs to be applied permanently, so there should not be any lost or subsequent failures, so due to some errors which are going to occur during the transaction. So that type of durability or permanency should be existed for a database. Means whatever the changes we are doing, it needs to be get reflected to the database, and then it needs to be stored permanently until and unless once again the data will get changes. So if any failure or lost occurs, still also the data needs to be permanently, it needs to be stored as it is, whatever it is previous state. That is what we are calling it as a durability. These are all the four so desirable properties of the transaction, so which we are using during the transaction process. Now the how these transaction or desirable properties of transactions are enforcing into the transaction or implementation of the transactions. So these are the properties which we can implement by using some of the protocol. By using those protocol we can apply or we can maintain these properties so in the transactions. So the first, atomicity is one of the desirable property of the transaction where which can be enforced by the recovery protocols. These are the protocol which we are implementing whenever the transactions are undergoing. Through this protocol, the atomicity property can be maintained. The consistency preservation. This consistency preservation is also the second property of the transaction, which is specifies that each transaction does a correct action on the database on its own or not. That we're going to check by this property. So this property will be implemented either by the application programmer and or else by the DBMS constraint. What type of constraints which you want to implement for your database. So based on those constraints, you can also enforce these responsible for consistency preservation. So this is the how we are implementing the second property for this transaction or desirable property of that transaction. And the third property implementation is it is the responsibility of the concurrency control protocol, where this concurrency control protocol will maintain the isolation. Means whenever concurrently if n number of transactions are executing, we are isolating each and every transactions from each other. They should not interact or else there should not be any disturbance in between. So for all those transactions which are concurrently or parallelly we are executing, that concurrency control protocol will going to manage each and every transaction execution, and that will be monitored and maintained by this isolation. So this protocol will be the responsible to maintain the concurrency protocol. Durability or permanency. The durability and permanency which is also is enforced by the recovery protocol, where we are going to store the data permanently. So if any failures occur, then there should not be any violation of the data. In that manner, we are going to store the data into the database. This is about the how we are implementing these properties of asset properties or desirable properties of an transactions. Next is schedules of transactions. The schedules of transactions is nothing but when there are n number of transactions are undergoing, how we are scheduling those transactions, like with respect to isolated manner or else by using those asset properties, how we are maintaining or managing the transactions. And before that, we will identify how the transactions will be scheduled in the database. So the transaction schedule, or we can also call it as history of a transaction. When transactions are executing concurrently in an interleaved fashion, the order of execution of operations from the various transactions will form what is known as the transaction schedule, or we can also call it as history of a transaction. So let us consider a figure in the next slide which will going to show four possible schedules. There are schedule A, schedule B, schedule C and schedule D. There are four possible transactions of these schedules are there. Of two transactions are there, that is T1 and T2. So with respect to that, we will see how the schedules are made for these two transactions, that is for T1 and as well as T2. The first, the order of the operations from top to bottom, always the order will be starts with the top and it will end with the bottom. Each schedule will going to include the same operations like read, write, commit. Okay, those are all. So some of the operations that are all included in each and every schedules, and different order of operation in each schedule. Means the order of the operation will be there, that will be different from each and every schedules when we will compare with the diagram which is shown in the next slide. Now you can see these four figures. These are the examples of the serializable and non-serial schedules, so which are involves for the transaction T1 and T2. So now you can see the schedule A is there. The schedule A which is included T1 transaction and as well as T2 transactions. So the transactions will be always from top to bottom. Therefore, the time will also given with the arrow mark top to down. But that is nothing but arrow mark will be towards the downward. So where T1 so and as well as T2 transactions are there, you can see the T1 transaction will going to perform some operations like reading the item of the X from the database, and then it will going to perform some task where X is equal to X minus N, and then after updating the X value we are going to write that X value into the database, where the updated value we are writing it back to the database. And then once again the T1 transaction will be reading the item Y. So after that it will be performing some addition operation, that is Y value will get updated with this Y plus N, and then we are writing the item or updated value of Y back to the database. Means so up to the transaction T1 is there, that will execute first, and then so the T2 will starts to execute. Therefore this schedule A, we can call it as these kind of schedules, we can call it as a serial schedule, where completely T1 will execute and then T2 will starts and it will going to execute. Similarly, when I go to the schedule B, you can see here in the schedule B, first T1 will execute first, and then next T2 will execute first and then followed by the T1. So this is kind of, so the complete execution of the T2 will be done, and after that T1 will go and execute in this schedule B. But these schedule A and schedule B, totally we can call it as serial schedules. When so schedule C and schedule D are there, we are calling it as non-serial schedule. Why? Because so in this the T1 will execute first, and then interleaving operation will be occurred, then T2 will execute, next once again T1 will be executed, then T2 will execute, next T1 will execute, like that. If the operations are switching between the two transactions, like T1 first, next T2, next T1, next T2, this kind of operation we can call it as, so here there is no any complete execution of one transaction where in between the switchover will be done or interleaving operations will be done between the two schedules. Therefore these kind of schedule we can call it as non-serial schedule. Similarly, when we go to the schedule D, you can see here first T1 will execute, then interleaving operation will occur, and then T2 will perform, and once again interleave operation will be applied to the transaction T2, then it will be given back to the T1, then T1 will execute, like that the operations switches from one transaction to another transaction. So in that case these kind of schedules we can call it as non-serial schedules, or of schedule C and as well as schedule D are the examples. So now we will see how this schedule can be represented, which are shown in the figure previous slide. So the schedule can also be displayed in more compact notation manner. Okay, so I will show you how we are writing the schedules in a more compact notation manner. The order of the operation we need to always consider from the left to right, and then so the transaction will basically includes these notations, like for a read we will be representing it as a small letter R, and for a write operation that will be represented by using a small w, and their transaction IDs will be represented by using a 1 2 3 4 5 dot dot dot, and item names are there, that is which item or value which we are reading from the database and we are updating and then we are storing it back into the database, that will be represented by using always capital letter X, Y, Z or A or B, so values. So this is the some of the notations which we are using, or compact notations, to display the schedules. Then can also include other operations such as B. B stands for begin, E stands for end of the transaction, C stands for commit of these transactions, and A stands for small a, so we can call it as abort or termination of the transactions. These notations or operations, so our compact notations are also we are representing to represent our schedules. Okay, and you can see from the previous example, so those previous example we can write by using these compact notations, like schedule A, so where R1 stands for transaction T1, so if R2 is there, then it indicates that transaction T2. So with respect to that, we have written this schedule. Always the operation or order of the operation should be from left to right. Okay, therefore, so the schedule A, so that is R1. R1 stands for transaction 1 reading operation of a object X. Then W1 stands for the transaction T1. So we're going to write some objects X, and then R1 indicates that it will going to read some value or object from the database, that is Y, and W1 of Y. W stands for writing of the operation with respect to the transaction T1, and then so that is a Y item into the database. Now you can see here R2 is there, that R2 indicates that so reading of the data item for the transaction T2, so of X objects, and writing of the X objects into the database. So for that operation will be undergoing on, so in the transaction T2. So like that, so the schedule A has been displayed. Similarly, when we'll go to schedule B, so where R2 of X, where we are reading the data item, so from the transaction T2, that will be performing the operation of read operation, that is the we have written R2 of X, where object X is reading, and W2 stands for we are applying the write operation in the transaction T2 for object X. Similarly, then R1, so of X, W1 of X, R1 of Y, W1 of Y, these four operations are there which are related to T1 transactions in the schedule B. So these two, schedule A and schedule B, we can call it as serializable schedule. Schedule C and schedule D are there, that will be represented or non-serializable schedule or non-serial schedules. So where similarly where R1 indicates that a transaction of T1 where reading operation is undergoing, then W1 indicates that transaction T1 will be performing the write operation. So where W2 if it is represented, then it is indicates that transaction T2 is doing the writing operation of that particular object. So these are the some of the compact notations which we are using to represent our schedules or transactions in the transaction management system. Now, so we are going to discuss about the formal definition of a schedule, how we can formally define a schedule or a history of a transaction. The history of a transaction or a schedule will be written it as a S of n transactions. For example, there might be T1, T2, T3 up to Tn transactions. Then, so we can define a formal definition of the schedule in this order. An ordering of all the operations of the transactions subjected to a constraints that for each transaction Ti that participates in schedule S, the operations of Ti in S must appear in the same order in which they occur in Ti. There is a one major important point: the operations from other transactions like Tj can be interleaved with the operations of Ti in a schedule. This is the formal definition of a schedule or a history of a transaction.